This is Josh Knight. He is the tunnel agent at Balfour's VINCI, working on HS2 Bromford tunnels. He has managed the completion of TBM Tunnel Drive, which broke back in May 2025. And prior to his work for HS2 N1 and N2, he has worked for Tideway East as well as Hinkley Point C. And right now, Emrah is there on stage right now. So
yeah, I'll start. Yeah.
As he's starting. So Emrah is the engineering manager at Balfour's VINCI, again leading the engineering delivery team for HS2 Bromford tunnels, as well as the long Inchlington Wood tunnels. Apologies if I butchered that name. He has around 20 years of experience delivering major tunneling and underground infrastructure projects across UK, Turkey, and the Middle East. That sounds like good money.
Good market rate.
Yeah.
Good evening, everyone. We weren't expecting such a turnout, really, but yeah, really good to see you all here. Today we talk about compressed air working at Bromford and why we needed it, why the engineering decisions mattered. And usually on every project, every TBM nowadays, you're prepared to do it, but you never do it, which is good. We always avoid to do it, but this time we had to do it on each TBM, so we wanted to share the experience and a bit of knowledge with you as much as we can. I'll set out the context, give you the introduction about the project, talk about the critical assets along the route, the ground conditions, and the strategy behind our interventions and planning around it, planning of the works, and then hand over to Josh for the execution on site and the preparation and the post-cycle work, and a bit of lessons learned, what we can share with you today. Just a regional overview to share with you about this is the BBV stretch of the HS2 phase 1 area north, about 90 kilometer stretch. It starts just north of Simdi with the Long Inchlington Wood Tunnel, which was our scope initially. It was completed before Bromford tunnels. And after the Delta spur, which is magenta, towards west into Birmingham city centre, last tunnelling section, Bromford Tunnel, 5.8 kilometre long bore, which we will talk about today mostly. Focused in to how it looks, starts from the Waterauton towards the west, follows roughly M6 and ends in the Washwood Heath West Portal, the reception site, before reaching the Birmingham. Bit of key numbers about the Bromford Tunnel. So twin bore, 5.8 kilometres, 8.6 metre excavation diameter, very asset constrained route along the corridor. The maximum depth cover 39 metres with 5.5 metre low cover on the river crossing, which was one of the tightest sections for us. And within the zone of influence of the tunnelling, I will say the EA, River Tame, multiple crossings, the national highways, some highly strategic utility corridors passed underneath, and some other assets, private assets. And in this zone, we also wanted to have interventions carried out. We had 13 cross passages for phase mapping purposes for future works, an intervention, even though they are not in the best places to do it. So I prepared a short video of it to give you a bit of a visual cue of how the alignment looks. This is just after the Delta Junction, after you've seen the magenta, turns to the left into Birmingham Centre. So it starts with the Waterauton cutting. Hopefully video starts, yes. Waterauton cutting, we're just north of M6, the residential area on the north with the North Warwickshire Council. It's a really narrow, long strip. For East Portal is our launch site and logistics site. After that, STP1 and STP2 follows. Then we start hitting the assets along the route with the Birmingham Road crossing and NSO pipeline underneath. Site office is right behind it. The verification zone is a greenfield area right behind. I'll explain later the importance of it. Surface level changes about 20 meters drop, and then we go into the nature zone, which not very accessible. 90% of the year is flooded with the national grid assets along the route. So nature reserve and River Tame, and the tunnel alignment. If you didn't not to crowd it, but it's roughly in the center of the video. And network rail lines, Birmingham Derby line, we cross with the TBM right next to along the embankment, and we reach our first river crossing as soon as we clear the nature reserve. After the first river crossing, we have substations, multiple assets, and SO pipe crossing, and industrial area with sensitive machinery for vibration. Right after this point, we reach our midpoint with National Grid Tower 20 and intermediate shaft. And we approach the warehouses and multiple 7 Trent assets buried. Our second road crossing is the A452 and buried service pipes with also sensitive open reach assets, where we approach our M6 Bromford Viaduct crossing with the river crossing. M6 Bromford Viaduct is the longest road viaduct in the UK, and it's quite aged one. We could not pass underneath until we strengthened it. That was one of the big items on our list. And then we cross, I think it takes about 300 rings to cross it. Both drives are in that green field between the house and the M6, and we cross the National Grid towers one after the other with Cadent gas pipe. It's a quite high pressure line as well, strategically important. While we cross this greenfield zone, it's relatively gets easier, and then we approach another river crossing and National Grid pylon right next to it. This is our third river crossing. So immediately after we get to industrial buildings and some machinery again, and our last road crossing, A47, and the retaining wall with multiple assets buried. After this, the most challenging one before the West Portal is low cover crossing. As I mentioned, it's 5.5 metre cover, and we reach the West Portal reception. So to summarise, the Bromford Tunnel Drive is a shallow and asset-constrained area. So when we planned the intervention, this was obvious. We would likely need a hyperbaric preparation in any case. The second restriction, the constraint in the geology and the ground conditions, the profile mostly within the Mercia mudstone, different grades, grade 1 to 4. Grade 1 and 2 is the best part of it, the rock, and 90% of the drive is within it. Grade 3 soil, where you see in the first bit on the right hand side, was highly weathered, gravelly clay, and with extremely high permeability. When we stack those constraints in terms of assets and the geology, it takes a good chunk of the area and highlights it not suitable for atmospheric intervention, but depends. If we were in the MMG 1 and 2 grades with really low permeability, that was not going to be an issue. But again, preparation made it even more important at that stage. And that's why we engaged with Tonner Ridley Hyperbaric Associates early in the project stages to become a compressed air contractor to manage almost all aspects of the preparation, from the medical surveillance, setting up of the plant, inclusion in our health and safety teams, and having on site on 24/7 for readiness. Reasons for interventions, it's always obvious for in many cases for TBMs, the blockages, worn out tools, wear, the extreme, the flow restrictions, and it was a VD machine. Later on we will explain, Josh will go through it. I didn't want to repeat it. The blockages that causing flow restrictions, steering difficulties and roll, that these are the main issues. And we know these happen, and we want to plan ahead for it. So, and if we ignore these indicators, there's a chance that we might have to stop in an area we definitely don't want to stop. So, therefore, we need a clear intervention hierarchy and a plan and zoning, which is what I'll show next. The intervention strategy is escalating. Obviously, we want to prevent and avoid. That's the best case. But we know that's not possible because we have to go in, do face mapping, even if you don't make any tool changes, And if you can't be if you can't do it in free air, the next escalation is compressed air interventions, but only if the ground allows and is feasible in terms of readiness. The ground improvement and ground freezing options are the last option, because the third option is going despite difficulties, operational difficulties, if you can't do compressed air interventions. What it does and what it doesn't, it doesn't substitute for ground support. We cannot rely on it for failure of the ground. It does help reduce groundwater inflow, and that's what we rely on. We can't just crank up the gauge to increase the pressure, because there's a risk of blowout, Roy mentioned, which happened a few times in different places, not with us. And likelihood of ground disturbance, because I've shown you the assets, number of assets on the surface and subsurface. And there's a high risk of causing decompression illnesses, health risk to operatives. And as you go up above 3.5 bars, it brings operational complexity with the working time and air mixes and decompressions. Which one to choose, which one to go for? It is simple, really. Free air is always preferred, if inflow rate and stability of the ground allows us. Then the next step is compressed air, but only, as I said, if it's feasible and if you're ready for it. This is an early sketch to show the decision, how we made the decision behind it. The colored zones highlights where within the MMG 1 and 2 grades usually. If on the underend conditions, if the flow is, which is a number we roughly came up with, less than 5 cube an hour, we can do atmospheric. It was the first condition to check, and in some areas we had to do hyperbaric intervention up to 3.5 bar, either due to asset or the ground conditions, or to reduce the water inflow. And there are some areas you can see no intervention allowed whatsoever. It could be due to faults, low cover, or very sensitive assets, as per the later on I will mention the ground movement assessments. There are obviously limitations of the compressed air working. The main one is the human performance. As the pressure increases, it does have effect on us, although we are very good to adjust ourselves to changing pressure over time. There needs to be considered as a performance limitation as the number of people reduces away. Workforce availability, there's strict requirement for hyperbaric fitness certification, and has to be fit on the day of work. There are limited pool of trained operatives, and every time we start on a new job, in this case with TRHA, we did set up the initial testing and medicals to have sufficient number of people on the project. It's highly non-productive time compared to free air interventions. You can go in and out very quickly. You can change number of people very easily. And when you have the compressed air, you have to follow the procedure, and you have very limited number of people allowed to do it, able to do it. The system and operational constraints, the whole setup must be fully functioning with the backup system for resilience. You cannot give a go-ahead. You can give a green light unless one of them, any one of the items not working. Outside of the engineering intent, there are also other constraints which I won't go through all of them, but the medical fitness, I mentioned, they have to be annual and interim assessments, and the operatives have to be fit on the day. They can have cough, flu, colds, they won't be allowed in. And that reduces our availability by chance, depending on the season. Impact on the planning, you cannot have one gang very competent and suitable and fit for intervention, but the others not as good, because if they're off on a long weekend, then the work stops if you have to do it. Environmental constraints is not a big problem in the UK for now. As the wet bulb is not really a problem, but temperature, humidity, they're all controlled by the lock attendants and managed. And the changes in the surface weather might impact the reliability of the system setup. The chart is quite interesting. This is one of the records of the monthly hyperbaric committee meetings. BBB set a threshold of 25% of operatives to be fit and available for hyperbaric intervention at any time. But you can see we rarely hit that number, went above it. That meant we weren't quite ready for every gang at any time. So they'll take away really the availability is not equal to work size, so it has to be trained and kept under control. For governance and decision making, as mentioned hyperbaric committee, we need it. We have to be compliant to HSC. The notice period I mentioned, it's in the guidance. We have to give notice to HSC that we will work on the hyperbaric. Even if it's under 3.5 bar, above 3.5 bar, the exemption is required. One of the reasons we worked with TRHA, we knew they received this exemption on the previous project, and they might be first in the UK. I'm not quite sure, but it's rare to get that. But the committee functions and as part of the planning, construction, plant and hyperbaric teams gets together, decides on the scope of intervention, and they can challenge it, then you can abort it. The outcome of it is of the meeting. They can defer, they can change the scope, and they can place hold points and abort decisions if need to, and to exit cleanly. The governance is aim of the governance is not really making more paperwork. It's just to plan ahead of the TPM and be ready when it comes to for intervention. Wanted to make a bit of a visual risk assessment. If you see on the left-hand side the threats that drive us to the work, the catalytic intervention, and the control measures are layers of safety to try and reduce those possibilities, like tool inspection, fitness screening, controlled operational parameters to limit advance and speed, pre-entry checks, zoning that we've shown you on the map, how you define the zones, the safe areas to do it, and on the right-hand side the recovery measures. If it goes in a bad way, how you exit cleanly and abort safely with no harm to anyone. That in that case, the layers for safety, additional training trials, hyperbaric MLAs on the TBM, watches and lock attendants, backup systems, validated oxygen decompression tables, which was supplied by TRHA, and being ready for emergency response and ready to take people out, just to prevent the blocks on the right-hand side. The worst case scenario options, the injuries, the decompression illness, the ground movement that we don't want, uncontrolled ground movements, flooding, and ultimately cost and schedule overrun is one of them. But obviously safety is the first for hyperbaric works. As a snapshot of the outcome of all these works, so what we produced, a drawing that can be utilized by every shift, instead of looking at the reports and the assessments and all that, a huge amount of paperwork behind it. So shift teams had information right in front of them, ring by ring, which zones are they in, what's the risk range and the pressure range, what's the expected cutterhead intervention zone, and the planned area. It just made put everyone on the same page and kept everyone ready, so nobody questioned each other. One of the things after we checking all the boxes and preparing and planning for interventions, hyperbaric or atmospheric, we went on to testing and verifying the ground response, because to satisfy the asset owners for consenting and receiving no objections, we had to show them that we will not impact their structure. So the first test was behind the offices. I mentioned the verification zone in the greenfield zone. 2 extensometers about 70, 80 rings apart. You can see each level, the closest one on the XR02, 2.7 meter above the crown, and 7 to 10 meters apart, other sensors reaching up to surface. You can see under confinement pressure, only the lowest sensor moved about 1.5 millimeters settled. The rest of the sensors, a bit of noise as along the TBM passing, you can see it change. Then there was no impact whatsoever under confinement pressure using this machine. Very strict operational parameters, but worked really well. On the 80 rings after, still in the MMG 1 and 2 grade, XR05 this time, only 2 meters above crown. You can see initial impact, and then very small settlement to 3.6 millimeters. This one, the trial was slightly lower pressure to show the difference, to understand the effect, but still on the higher sensors and the surface, there was no movement whatsoever under pressure. So that was really helpful for us to understand the impact on the confinement pressures on the Mercier mudstone. Another test we've done was on the atmospheric. This was again in a verification zone where we had a piezometer and we had the surface array for settlement control. During the intervention, about two days, we seen 5 millimeter settlement on the surface, which is not big, but compared to our strict constraints on the, for example, National Grid towers, 5 millimeter in a differential settlement, we're reaching a red trigger. So that would not be allowed. But as you see, as soon as the intervention finished, after about 2 days, when the confinement pressure applied, slurry pressure applied on face, we see immediately about 2 millimeter heave, and as soon as the TBM passes, we almost weren't even there on the surface level. No change whatsoever. And on the piezometer as well, same. You can see average 160 kPa measured, but small drop in there, about 50 kPa drop in there during the atmospheric intervention, and recovers immediately after intervention. So that gives us a really good idea of what would be the impact if we had to do intervention, atmospheric intervention, nearby an asset, and that helped us a lot in the AIP processes. And now I hand over to Josh to talk about the works we've done in the preparation and cycle. Thank you.
Thank you, Emrah. So I'll just go through more the practical side and what we actually did in practice to do the two hyperbaric interventions that we did. So just a bit of a background first on the type of machine that we were using, Bromford for both drives. So we had a variable density TBM, so I'm sure many people in here are aware of what that is and how it works, but just for those who aren't, so there's basically 4 main modes that you can mine in. So you've got a standard EPB mode, EPB mode with bentonite support, low density slurry mode, and then mixed shield slurry mode. So those are the 4 different modes that you can basically mine in with this type of TBM to give us a bit of variability with the changing ground conditions. For the cuthead intervention itself, obviously the VD machine is pretty standard in terms of its setup with a cutter head and excavation chamber. You've got a bulkhead and the air bubble behind. You've also got the lock for access of personnel into the head. So we had a standard inline lock on this machine, so with an entrance chamber and main chamber before you then enter into the air bubble area within the bulkhead. And for this type of machine, the excavated material is basically taken up through the screw like it would be on an EPB machine, but after that, when it gets to the top of the screw, it will drop into what's called a slurrifier box, be mixed with slurry, and then it's pumped out of the TBM via a slurry circuit to the surface to a slurry treatment plant and then separated and dealt with that way. So that's just a bit of a background on the type of machine we were using. For the cuthead inspection, this just gives a bit of an idea of the ground conditions that we had and we experienced before we did hyperbaric works. So we did several interventions before we actually did the compressed air interventions. So you can see on the left image before cleaning, it's quite cloggy material, as Emrah's previously mentioned, so there was quite a lot of cleaning required to actually access the cutting discs before we could change them. Obviously, once we had accessed them, we can do all the tool measurements, and after go into the inspection of the knives and the other tools on the cutter head. So compressed air working at Bromford, so why did we need to do it? So we were approaching a no stopping zone, which was one of the network rail assets. We had a reduction in the TBM performance as well, so like some of the issues that Emrah mentioned, we had an increase in roll and torque. The ground wasn't stable during an attempted free air intervention on the first drive, so you can see from the images that was kind of the ground conditions and the face conditions ring 213, so we'd done a few free air interventions before. We were planning and stopping to do a free air intervention ring 721 before we went under the network rail asset. Whilst we were in there, the guys were in there for a few hours, water ingress, everything was normal, and then they basically noticed some of the ground started coming in from above the top of the shield, which you can just about see from this video they took in there, so kind of creating a bit of a void above the shield. So that intervention was basically abandoned, and we moved forward to try and see if the ground was any better in areas further forward. So those ground conditions actually differed slightly from the GBR, and that was subsequently a long process of going through and getting that agreed with the client, but basically that disagreed with what the GBR had said the ground would be. And then the lessons were learnt for the second drive, so obviously this issue was found during the first TBM drive. So the second drive, we basically adjusted the position of the intervention prior to going under the network rail asset to obviously avoid this area of known bad ground. But due to another reason, basically an ungrouted borehole, there was a loss of pressure where we tried to stop there. So then we had to move forward into this area of bad ground, hence the hyperbaric intervention was needed on the second TBM as well. So just to show the locations, so from the video that Emrah showed, so for the two TBM positions, the red line just on the left of the screen shows where the zone of influence started with network rail, and highlighted in red is the line as well. So the two TBM positions, so TBM 1 where we tried to do it, we attempted several times after we had that first issue, and obviously we're up to the point of the zone of influence where we did it. And then the second TBM was just slightly back from there. But that was within the nature reserve, which is an area that's flooded for most of the year, as Emrah's already mentioned. So that just gives a bit of a background of why we had to do the hyperbaric interventions. So going into the process of how we actually do it and what we need to go through on site before we get to the hyperbaric interventions. Obviously one of the main ones and the key ones is the pre-work medicals. So this obviously limits the risk to the workers and the guys who are going in there, and basically making sure that the people that go in there are fit and there's not going to be any adverse effects on their health afterwards. So the initial process that TRHA would go through to confirm fitness for the people is basically they do medicals, which is conducted by the contract medical advisor or HSE appointed doctor. So that's basically a comprehensive annual medical. So that's like your safety critical medical, plus some extra tests and checks. Once that's done and the operatives have passed through that medical, they then go under compressed air training. So that's specific to the project and depending on the kind of pressures and works that we would be doing. So that's kind of a classroom session that TRHA would do. Once they've done that, they'll then go into lock testing for working pressure on the project. So whatever the project pressures will be for what we're expecting based on the ground conditions, they would go into the lock that you can see that we had set up on site, and for a very short period of time they'd go in there, basically be taken up to the pressure that'd be on the project, check they can clear their ears properly, and that they're happy being in the compressed air environment. Because obviously the last thing you want is the first time that someone goes in compressed air is when they're doing it for real in the cut ahead of the TBM. And then we'd also do interim medicals every 3 months to basically keep checking on the operatives who are fit and ensure they were fit to do the works. Obviously the compressed air system and plant is a very important part of this as well. So we had surface compressed air plant up on the surface, so that had duty and backup compressors with 2 air lines which were run down into both machines. You've obviously got the man and material lock on the TBM, obviously making sure that you have a clear escape route as well. So you can see just on the right edge here, that's the material lock for transferring material through, and obviously the man lock on the top of the machine for the workers to access. Obviously the air supply, so you've got the compressors, pressure regulation, monitoring system on the TBM itself, and then the breathing system within the manlock as well for decompression, and monitoring equipment as well, which will be at the lock when the guys are going in. So before we started the works, obviously there's required notifications to the HSE that we're doing the compressed air works. As Emrah's already mentioned, and Roy mentioned as well, there's exemption required for work above 3.45 bar. But that's the first one. But obviously it's critical to notify other people on site, so other teams with HS2, and many large projects, you've got more than one team working there, so it's critical that they know the works that you're doing. Also key stakeholders and emergency services as well, making sure, and the client obviously, that they're all notified of the works that we're doing, and stressing the importance and the criticality of the compressed air lines, that there's no damage to them whilst we're doing these works. Obviously on our site you can see the compressed air plant was quite a distance from the actual tunnel entrance, with the pipes run on surface, and when we were doing these works, the civils team were actually doing works in the vicinity of that, so had to halt those works whilst this was ongoing. So the key roles and responsibilities that we have for the management on site can broadly be broken down into sort of 5 categories. So you've got your management and kind of technical, so that's overseeing. So your compressed air coordinator, they're basically responsible for the whole operation on site and overseeing everything for the hyperbaric interventions. You have your intervention supervisor, so they would be stationed down on the TBM whilst the hyperbaric works are going on. So they'll be down there with TRHA, so that's the contract hyperbaric specialist. You've obviously got your medical and health support, so obviously the contract medical advisor, which was TRHA in our case, man-lock attendants and surface medical lock attendants, so what's known as the MLAs. Obviously you've got the workforce, so the guys who have been trained and who are actually going in to do the works. Obviously operational and support crew, so you've got the TBM crew, and then we had a compression station attendant and a power attendant as well, so they were stationed whilst we were doing the works at the plant, just basically making sure there was no issues there at all. And emergency and safety roles as well, so we had a casualty extraction team in place on the TBM, especially trained for dealing with any bad injuries, trauma injuries. PIC, so your person in charge, and then basically pit bottom and communications coordinator as well, basically making sure that we didn't lose any of the comms for radio, Wi-Fi, etc. Whilst we were doing the work. So lots of different people that need to be involved and working together whilst we're doing it. So for the pre-start checks, obviously Emrah's mentioned a lot of the design and the background that went into actually understanding where we can do hyperbaric interventions and the pressures required. But the pre-start checks is obviously the regulations and guidance, which is the overarching guide and information for how we do things safely on site. We obviously have the RAMs, so RAMs from TRHA specific for the compressing works when they're taking the guys up to pressure, decompression, etc. Then also RAMs from us, from BBV, operationally of how we're going to manage the works. Pre-start planning meetings as well, so once we decided to do the hyperbaric intervention, basically making sure we have everything in place. We had a specific health and safety assurance as well from our health and safety team prior to starting the works to ensure that everything was in place and as it should be. Then you've obviously got to do the RAMs and the briefings to everyone who's involved, not just the guys that are actually going in and doing the works, but on the previous slide with all those people that are going to be involved in the operation, they need to be clear on what's happening. You've then got your permit process prior to going in and starting, hyperbaric checklist, and then TRHA before they go in will basically do their pre-work checks and a briefing on the TBM before they actually send the guys in. So it's really clear with all of those different stages that the communication is really clear between all the different parties, but also when the guys, before they go into the cut ahead, they're very clear on what works they have to do and what's expected of them for that duration of the intervention. The last thing you want is them to go in and then you're back and forth, you're not clear and they don't know what they're doing. You need a very clear plan of the works that they're going to be doing. So entering the lock and pressurisation, so we've got the SOTS cages, so that's the safe contained oxygen transfer system. So those cages are basically taken in prior to starting the intervention, and then they'll be connected into the system on the TBM to supply the operatives with oxygen whilst they're undergoing the decompression. And then on the right image there, you can just see TRHA, so the guys managing the lock system, so managing all the pressures with the gas monitoring, but then also in contact with all of the workers who are in there whilst they're undergoing compression, checking that everything's all right and that they're happy in the working environment. So hopefully the next video is going to work. I will say the workers we have, excellent at changing tools, not so good at working a GoPro, so we only have a couple of good videos, some good photos, but only a couple of good videos. So this just gives an idea of the kind of conditions that the guys experience when they go in. So this is when they've just gone under compression up to the required pressure, and then they basically open the doors, and this is kind of what they're first visited with within the cutter head before they actually start the works to go clean, inspect, measure, and then change any tools that are required. So just a couple more images just to show the kind of conditions that the guys are working in. So you can see here on the left image in there cleaning out the pockets to access the tools for the measuring and changing, and then here they're actually standing on the platforms near the main drive of the TBM, again doing the cleaning in to try and access the tools to measure and see if we need to change any before we go under this zone of influence. A couple more images as well, so you can see the clogging of the material above the discs. So this is what they had in there, and obviously wear on the discs as well. And then just another image just to show the kind of process with the discs that are taken in and out, obviously using the transfer system on the TBM through the material lock. So we had a few cutting discs that basically had flat spots on, so the guys were in there doing the measurement, and we also found within the Mercier mudstone as well, the tools weren't wearing as they would in other ground. So with the standard herring connector measuring tool that you have, basically the points of the discs were not actually wearing away, so they were still at the same basically dimension that they would be when we started, but we were actually getting a lot of wear in the centre of the disc, so it was wearing towards the bearing of the cutting disc. So that just gives kind of a bit of an image and a visual of the measurements that the guys were doing in there. So once they'd gone in, we'd obviously inspected, changed any tools that we needed to change. At the end of their working time, the guys would come out and undergo decompression, so you can see in the images there, with the masks on, with the oxygen breathing. So for us, we were doing the works at 2.1 bar, so the max working time in there was 210 minutes, so that's including your compression time. Decompression was 84 minutes, so your total exposure, you're up to 294 minutes. So quite a decent time that they could work in there to actually get a lot of work done whilst they were within the cutter head. So once that's been done, and you've done the works and the guys have finished their dive for the day, they'll come out and undergo post-work and ben watch. So they basically need to stay on site for a period afterwards. So they'll come out of the TBM, come straight up to the office for a shower, clean up, and then undergo ben watch under the supervision of one of the MLAs from Tony Ridley's. That's obviously just to make sure there's no issues as soon as they come out. They're also strictly instructed as well, no flying or ascent to altitude, so driving over mountains, etc. for 24 hours after completion of the decompression, just because of the change in pressures. The medical advisor doctor, so they're on call 24 hours a day during the compressed air works, basically just in case there's any issues. Once the guys have gone back home, back to the digs, between works, they can call them any time of the day, come back into site where we've got the lock, and we can address any issues that they might have. Decompression illness, so that's carefully controlled, obviously using the decompression procedures. You've got potential dysbaric osteochronosis, I think I've said that right, which is historically associated with compressed air tunnelling, although basically with oxygen decompression doesn't exist anymore really. Other barotraumas, so pressure injuries, or general injuries that they could have within the cutter head, which could be complicated by working within the compressed air environment and the time it takes to get them out from the decompression, and then obviously other potential health risks. So once that's been done, once we'd done both of the interventions successfully, we basically had post-contract medicals as well. So all of the workers had a final medical check, which was done by the CMA. And they also had MRI scans before leaving the project, basically as a contingency check for dysbaric osteochondrosis. So all of those were completed for all of the workers who undertook the compressed air on both TBMs, and no issues were found with any of them. MLAs also remained in place until both TBMs had broken through, even once we passed this area of known bad ground, and we didn't perceive that we would need to do hyperbaric works again. Basically undertaking essential medical equipment provision checks and other non-hyperbaric supports, but also to keep them in place till the end of the project, just in case is required. And the records of all of those works and everything that's done by the doctor needs to be maintained as well for 40 years, just in the event of any future issues. We also had an audit from the HSC after we'd done the works on the first TBM, before we did the second, basically checking through all of our procedures and that everything was in place as it should be. And they were very happy with the works we'd done. So I think it could definitely be considered a success, the hyperbaric works we did on both TBMs at Bromford. But there's always lessons learnt. There's always things we can do to improve and ways that we can get better and take onto the next job. A few issues that we had and kind of lessons that we learnt from our project was keeping the operatives fit and ready to do the works. So with a big job like HS2, there can be quite a lot of operative turnover. So people coming and going and leaving. People would potentially do the training, get themselves fit. They were classed as fit. But then when it came to actually doing the works, they didn't want to do it and didn't want to go in the cut ahead. So that was kind of a constant battle, an ongoing issue, making sure that we had people fit to do the hyperbaric interventions. Training of the operatives as well. So just because you have people that are fit and that can go in, doesn't necessarily mean that they know what they're doing within a cut ahead to change the tool, etc. So I'd say for next time, one thing we could definitely look to improve is to people that were fit but hadn't necessarily been within the cut-head environment before. We could look to send them in during free air interventions and train them up so they're more up to speed with changing tools and working in that environment. Preparedness of the documentation as well. So like Emrah had mentioned as well, so TRHA were involved with the job from the start. All the paperwork was there, required notifications were in place. But I think there's always a bit of a last-minute rush with some things when you come to it in preparing rounds, documents, and actually making sure that you have everything in place and you're ready to start. Time versus cost as well, for having TRHA 24/7, so you can pay and you can have the provision there to be able to do and start hyperbaric straight away, but that's not necessarily cost effective for the job, depending on whether you think you'll need hyperbarics or not. So again, that's one that needs to be weighed up, and keeping provisions until the end of the job. In this case we did on this project, but I've been on previous projects where we didn't, and it got a little bit hairy towards the end when you think you might need hyperbarics and you might not. So it's definitely one to make sure you keep that provision there right until the end of the job, because you never know what you might come into. Roy's obviously touched on this already with his as well, but this is just a few of the guidance and references that obviously we're working to, with BA 6164 and WICAR being the overarching ones, and then you've got the BTS guidance as well, which Roy obviously talked about. But there's lots of different guides that give you all the information you need to be able to undertake these works successfully, which I'm sure if you ask Roy afterwards, he has a lot more information on these than I do. But thank you very much for listening, and we will take any questions.
Thanks, Josh. Thanks, Emrah. Yeah. So first of all, I'd like to thank you for feeding my curiosity on compressed air working. You know, I've always been fascinated by compressed air working ever since I was labeled a health and safety risk in the emergency response plan. Really, if I ever felt unconscious within the manlock, I will be an obstacle for egress. So once I was restricted, I did offer my services as a manual bulkhead in case ever the locks failed, apart from being the shift engineer. But yeah, it wasn't accepted by the safety team. So first question. Yep.
How's this work? Oh, good. Ian Matthews, Specialist Plant Associates Limited. I noticed, I like to see the guys in the airlock decompressing on full face masks. There's been quite a bit of discussion in compressed air working group between full face masks and half masks, benefits of it, getting a full dose with a full face mask versus the discomfort, apparent discomfort. Was any particular discomfort reported by the guys using full face masks, or were they quite happy?
No, I think they were quite happy with wearing it, and I guess in our case, quite a lot of the guys didn't have any previous hyperbaric experience, so this was the first time they'd done it for a lot of the guys. There was a few that had, so I guess from the start they were trained using full face masks, so they were kind of used to it from the start. But no specific discomfort mentioned from any of the guys down there. No.
Okay, thank you. Roy, maybe a way to go.
They didn't know any better.
There you see.
The rest of the world, both in diving and tunnelling, use half masks. The only paper that did any comparison, everybody talked about the Ross paper, one of the compressed the hyperbaric specialist called Ross. When you actually read no bug had read his paper. When you actually read his paper, he does a comparison between hoods and half masks for geriatrics in hospital having oxygen therapy. Read the paper. Read the paper. He says nurses who can do it with hardly in training were okay on the half mask.
We also should have mentioned Specialist Plant, the locks and the other the components came from supplied by Specialist Plant. We should have mentioned these. Sorry.
Next question, Rosa.
Yes. Just I wanted to ask you how many interventions, hyperbaric or otherwise, you had to make in the tunnel, and did it differ from what you were expecting initially? And was it, what were the problems that you encountered? Was it wear of the tools or clogging? What was the most frequent issue?
Do you want me to say that one?
To start with, we weren't planning any hyperbaric interventions. It was always the first choice, free air. And for TBM1, first just mentioned, we had to defer it to find a better place to do it. On the TBM2, we knew the zone that is weak, and we tried to do it a lot earlier, and we hit a badly decommissioned borehole, so we had to approach that zone again. The reason you can...
Yeah, I think in terms of the number, I think we'd planned 21, 22 interventions, something like that, for both drives. I think on both drives we came just under that, so we didn't do as many as we'd planned. Like Emrah said, it wasn't planned to do hyperbaric, it was only one. I guess the reasoning was quite varied. At the beginning and in that area of poor ground there was a lot of clogging, so we were going in there was a lot of roll for cleaning. Towards the end of the drive we hit large bands of siltstone, which was actually cracking some of the discs, so we had discs crack, would then get lodged within the slurify box or the pumps, so we would have to go in for that. So I guess the reasons varied depending on the section of the drive that we were in.
Thank you, Rosa. And just on the question of clogging, I'll take one online because it's about that. And as you know, mitigating the risk is in the first place of a compressed air intervention is about eliminating risk first, right? Mitigating clogging. So the question online is from Jayashankar KR. It was understood from the slides that the clogging of disc cutter was observed during the inspection in the excavation chamber. As part of additional geological studies, have you assessed clogging potential of clays available on the alignment, and whether anti-clogging agent was proposed as a mitigation measure? Or even shrouds could be provided on the cutter housing to reduce clogging risks on the cutter head?
It's a good question. Yeah, the clogging issue is we are in the Mercia mudstone. It's classified as rock, but when that material turned into slurry medium, it turned out to be very clayey and sticky. So even though it's within slurry medium, it started blocking the openings and getting into the areas. For the agent. No, the slurry medium was the fluid agent. We didn't use anything bentonite either.
Okay, thank you. I think next question is from Nagin at the back.
Hey, thanks so much. That was very interesting. This might be for Roy. Forgive my ignorance of not knowing everything on the standards, but are those medical examines that needs to be happening before anyone starts working is based on strictly male bodies, or are there any female criteria? Because there are different lung capacities, all of that. I know there is not that many of us in tunnelling, but
That's a very good
There is
question.
no
that one.
differentiation in the regulation. At various times within the medical fraternity, there's often been a debate amongst, because the one thing that potentially affects females doesn't affect my side of the room is pregnancy, and that's a big unknown. One of the people who contributes to the compressed air working group is a physiologist involved with the Naval Medical Centre in Gosport, and it was one of the things they were quite concerned about with when the Navy introduced equality in going to sea, is if anyone was on any of the nuclear submarines who would be submerged for very long times, and that was a thing that they addressed then. But other than that, it's recognised as something that the approved doctor or the contract medical advisor would discuss with a female at the time of the medical, because that's about the only difference. Other than that, the physiology is much the same, and it's a balance between equality, but there's always that thing to actually discuss with someone. But that's left very much to the contract medical advisor at the time of the thing. So if you put your name down, have a chat with the CMA at the time.
Definitely, biology is a factor to consider.
To add to that, there's some of the MLAs are female.
Yeah.
Yeah.
So there's
Yeah.
no reason why not.
Yeah.
I mean, I'm sure there's no reason to why not. More that is, will we find out in a year's time what impact has that had on females who worked on this type of work without considering the physiology? But thank you anyway.
Well, it's something that it has been discussed. It is discussed among the medical fraternity, and it's always logged as something that the medical advisors should discuss with someone at the time of their medical.
Definitely, I've read somewhere osteonecrosis does affect more for women in terms of the bone health deterioration is more, but that's a topic for a different seminar in place. Yeah.
That's more with osteonecrosis generally,
Yeah.
rather than that. As Josh said, that the reason there's now a study going on with scanning for disconfounded osteonecrosis is there's none reported, but therefore in order to not to prove that, to register that, you need a study to say we have checked and we haven't found it. So that's the reason now, as Josh mentioned, not just post-employment but probably pre-employment MRI is recommended in the guidance at the moment until that can be published, because one of the things that comes up with a number of things is people always want to look for published references to look at. When Andy Colvin did a paper on PFO, which is probably former not Hogan hard anyway, one of the things he found, there is no published information or study about the effectiveness of oxygen decompression. Everybody accepts it's a great thing, and yes, it's been very successful. He couldn't find a reference to tuck into his paper in the bibliography to say it had, and therefore that in itself, a couple of people are trying to put forward a paper now so that they can have a reference on that. But with the dysbaric osteonecrosis, yes, within the diving fraternity, they don't check for it because they accept it isn't there. But somebody says one should have a proof of that.
Probably move this topic to the International Women's Day we are celebrating on the 26th of March. Good topic for debate over there. Thank you.
Christoph Scott one. Hello, Christoph from BMO Tunneling. I have a question to you, because you showed this nice tunnel band with the different areas where you have, where you can go into free air or what pressures you need. I'm assuming this comes from your phase pressure calculations. Did you have, because you mentioned that the geology was a little bit different than what you expected, did you have any parameters from your calculation, like from the slurry or from the torque, that you monitored during the drive, which would tell you, yes, our assumptions from the calculations are correct and we are in the geology which we expected to? And if so, how did you have an indication that the GBR was then different to what you actually expected and why you couldn't do the free air intervention?
So the difference in GBR comes from phase mapping, actually, initial phase mapping. The MMG3 soil area where we talk about, well, MMG in Mersey Mudstone in general is soft to very soft rock anyway, and an MMG3 soil grade is gravelly clay. It's highly weathered, and the GBR it showed that area to us. It was about 300 meters, and but in reality. It extended to around 1,100 meters. So we initially assumed we can pass that zone with no intervention. So we do one intervention before we reach that point, where we had ring 200-ish. And then we go through that. Even if we have any operational difficulties, we just go slowly, but we pass that zone. But as we gone through it, we just never ended. The area you see on the nature reserve, that all of it is MMG3 soil. It could be historically river and that area. Operational parameters, not really, because the material is really soft. You don't see a big difference. There was a quite big change in roll, shield roll, in our case. That could be an indication. We have to look at it really to see if it made any big difference. But that also coincides with the time we installed the anti-roll on the shield, so that might skew the results. So we have to look into that. That's a good question.
Does it include bentonite parameters? Did you check them? Did you measure the bentonite? Because you said you excavating with the screw and then adding the slurry later.
The slurry added, but slurry does not include bentonite. It's just water. No bentonite in our case.
Thank you. Mr. Saville, next question.
Hello, thank you. In terms of the efficiency of the operations when you're in an intervention, did you go for it as we will target a certain arm or a certain set of tools, or was it just get in there, dig everything out, find which ones need repair or replacement? Or was it all planned out? You'll go through different places at different times?
Yeah, so I guess with where we were going under, it was quite a long stretch under the network rail asset, so sort of 500 to 600 meters that we were going under that. So we were basically doing a full inspection of the head. So the guys completed basically the cleaning of everything and then went and measured arm by arm. But after the first one and for the second one and for future interventions, we saw that quite often it was the gauge cutters sort of on the extremity of the cutter head that were basically, they were getting clogged and sticking and getting flat spots, so we quite often knew that it was those that we had to change. But for the first one, no, it was definitely just go and measure everything, check everything, then change what we had to change.
Hi, my name is Michael Tinning. I'm with Gold's Idler. Thanks for the presentation. My question is about leaks or leak detection when you're compressing the chamber, and kind of time frames. What's your kind of procedure starting the compression, determining it's okay for your guys to go over and the compression is holding? Just curious to know a bit more about that.
Talk about caking and all. Caking and you could take it.
Yes, so that's part of the hyperbaric specialist role, is basically ensuring that the lock and the lock system is fully maintained, operational and working prior to the guys going in. So they're not just when we do a hyperbaric intervention, they're in there every week doing weekly checks, basically checking all of the systems, all of the seals on the doors and everything prior to that. They'll also, before they send the guys in, they'll pressurise the lock anyway and leave it for a set amount of time, and you can see on the gauge if there's any pressure loss, which that's part of their kind of pre-checks that they'll do prior to sending any of the guys in. So in reality, they've done those checks before, so there should be no leaks. But in terms of leak detection, like you're asking, you'll see
in terms of ground, leak
or
to the ground,
ground, sorry.
into the ground. Yeah.
Ground side of things.
It's obviously caking first, bentonite cake to reduce the penetration, and inject the compressors have enough resilience and the capacity to change that to, what do you call it, oversupply if there's a loss, but that there shouldn't be. Before they enter, it's pressurized and checked anyway to see how many liters of air a minute going in. So they would understand. And if there's a need for recaking, let's say, they have to get out, make it safe, and then bentonite is injected again.
So on that point, we were only running on day shift because of the amount of optics we had available, basically. So we were just running two dives per day on a day shift. So on the night shift, we were basically recaking and refreshing the bentonite cake ready for the next day for the guys.
What's the kind of ballpark time it takes to compress the chamber before you go in to work?
With people, or without? It depends on the pressure applied. It's minutes to put in without people, but based on as well, that's where TRHA comes in. They have validated decompression tables. So depending on the pressure range we define and agreed, if it's 2 bar, 2.5 bar, 3 bar, there's certain compression time, work time, limitation, and then decompression time. For the applied pressure 2.1 bar, I think just put the numbers on the...
Yeah, are you asking in terms of the compression time, how long it takes to get them to the pressure?
Just to get the irregardless of people.
Yeah.
Without people, minutes.
Curious.
Minutes.
Yeah.
The huge capacity in terms of air.
Yeah, very quick.
On that note, there's an additional question online. Says, what was the minimum time period kept for a diver between two interventions?
Between two interventions.
As in the time off between interventions?
Yeah, minimum time period.
So, minimum time period that they would have, I think the minimum from the regulations is 12 hours. But basically they would only do one a day. So we were only on day shift. So, for example, if you're in the morning shift, they would be going between sort of 8 a.m. to midday. They would go back home, back to the digs, wherever, come back the next day to start the next dive at 8 a.m. the following day.
Thank you.
Thanks, gents. Just going back at the question, really. You said on the first intervention you did pretty much a full face inspection, all tools, big machine, lot of tools.
Yeah.
How long did that take, the full duration of the intervention in compressed air? And how long would it have taken if you'd have done it in free air? Just looking for a comparison.
Yeah, that's a good question. So, with the availability of the operatives we had, we basically did two sessions, two dives per day. So we started for the first machine on the Saturday, and we were complete with measuring and changing the following Friday. So we were 7 days for the hyperbaric interventions. Standard intervention that we would have where we were measuring all tools and changing, working day shift and night shift, 2 days.
4
max.
shifts.
Yeah,
4 shifts.
Yeah.
4 shifts compared to 14,
Yeah, basically.
Thank you. I mean, my question is very general. In terms of what you actually plan to do, this amount of work, the time duration that you initially planned, and then with these various challenges that you were faced, how did the delta look at, as in probably this took you more longer duration to complete your full activity? Could you just say a little bit more as to the plan to the actual work in the way you work because of this difficult condition of working?
In terms of general tunnel program for the TBM, we had interventions planned roughly about every 300-350 meters, and average day allowed in the program was 2 days per stoppage. Because of that and long duration of those works, we cancelled some of the interventions planned. We did gain some time, but we also lost some advantage in the face mapping for those cross passages. The other question was about the time it took.
Overall, for the completion of all the work, as to where you originally started from, and then when you finished your part.
Only the intervention?
Yeah. Oh no, the whole program.
The whole drive?
Yeah.
I would say hyperbaric intervention impact on the program compared to other delays we had is minuscule. Don't want to go into detail, but
and that's a fair comment.
Yeah. So, this is looking from a contractual point of view. So, who did take the liability?
Good question. I'm not sure if I should, but yeah, I mean, our statements from the works information says we should not have any compressed air interventions whole length of the drive. So any requirement for compressed air intervention was an almost automatic compensation event. Therefore, it was on client, the additional cost and time.
Thank you.
Thanks for your questions, everyone. And all the questions on the floor can go to the bar now. So we have 3 final questions. I'll take 2 from online, and then Roy will end as he started, so just to complete the cycle. So these 2 questions from young members online. First one is from Yi Wong, who asks, how does the manager monitor and supervise the works inside the chamber? Do they have to go through compression and go with the team, or do they use technologies instead?
So that's a good question. So the hyperbaric supervisor and the MLAs who are monitoring the locks and the works, they'll be on the outside, so they won't go through the compression with the workers. But basically there's a comms system, so basically like a radio system, so you can talk through to the guys who are in there. But also you've got windows, so it'll be visual with them as well, and they'll be checking in every so often basically to make sure that everything's all right. Exactly the same for the hyperbaric supervisor who's managing, so as they're getting information back on tool measurements or any issues, etc., they'll be relaying and feeding directly back to the guys who are working in there.
Thanks, Josh. And
To movie and find out about it, so go watch Cut Ahead.
Is that even a film?
Alicia online asks, in what ways can virtual and augmented reality simulations be employed to train TBM operators for hyperbaric interventions, reducing reliance on live compressed air exposure while maintaining procedural competence and operational safety? That will be a 5D experience.
That is a very good question. I guess that probably relates broadly as well to AI and general TBM operations, not just hyperbaric works. In my personal experience of managing these works, Bromford's the first time I've done it. I've been on other jobs where the provision has been there but not had to do it. I would say the stress and the strain that I had during that week leading up to it and then doing the works was probably the most I've ever had at work, being in different roles as the compressed air coordinator or the hyperbaric supervisor. Personally, from doing it, and when you're putting guys in there to change the tools, I would be very wary of using AI or a computer to manage that process.
I don't think you can replicate pressure on virtual reality anyway, unless you dive.
Sorry, can I suggest?
Go ahead, Roy.
The answer to that is not AI, but it's more robotics.
Yeah, exactly.
Over the years, there's a lot of interest. 1 or 2 companies spend a lot of effort into it, either having remote monitoring systems, so you can put a camera in to wash down and look at tools. Something in the future, I'm sure, robotic changing of tools is maybe coming, but there's always the balance as you're missing out on that human touch with actually seeing what's in there. But that's the probably, it's not the answer to the question he asked, but it's the answer he needs. And because there's
it's the answer he's getting.
Sorry, I'm sure. Yeah, I've worked with a number of people over the years where the trick was not to answer the question that they asked you, but what they really needed. You know, Mackenzie was a prime one.
Well, just so you know,
I think that's the thing. There's a lot of interest in it. There's a lot of work done in, I think, Miami with we, they call it the snake, where they could have something in the material lock that could come out and then do a lot of work prior to an intervention. And I think that's the best application rather than saying it's AI.
I think in terms of managing the pressures, that could definitely be automated, but you would always need that someone overseeing and managing that. You could never be fully reliant on that for managing.
Change the pressures?
Yeah, we changed it, but you know, with where you're managing the lock pressures, you always need someone.
Once you've set the pressure, maintaining it is straight. That is automatic.
Yeah, Samson.
brilliant discussion. Can you get to your question now, Roy?
Oh, well, it wasn't a question. Sorry. It wasn't a question. Well, thank you very much for the presentation. Very interesting information. You know, very good. Very nice to follow through a lot of what you're doing. If you give me, I could have given you my slide. You'd have done the Song and Dance Act as well. No, if you'll excuse me, a non-compressed air thing to pick up on. Another publication I like to plug because I did a lot of effort when it was being amended. You both mentioned the potential blowout or problem with an ungrouted borehole. There's a document from the Institute of Civil Engineers specification for ground investigation or site investigation. And I happen to be on the committee and chairman of the Pipe Jack Association when it was being revised in about 20 years ago. Put a lot of effort into actually saying, well, hang on, can we put something in there related to tunnelling? Because everybody whinges, says the SI isn't quite what we wanted. And therefore it's included in this ICAI specification for site as Appendix J. I always call it the tunnelling addendum. If you only ever read one thing about site investigation, is get a photocopy of that. It's only 1 page of A4. There's all the do's and don'ts on it. Grouting boreholes is fairly well up the top. Don't put them on the line of the tunnel is the other one. That's about the top two.
One of the reasons on that, it wasn't on the tunnel alignment. The tunnel is extended and covered that area. It was a viaduct in that area previously in the initial design. Maybe that's why.
That forgives us for one of the points. It's in my mind as well because a job I ran up in Newcastle way back. It was an open face machine with just a road header there. We hit a borehole and we were about 6 or 8 meters down. They all had this big whooshing, which in a 3.5 meter tunnel it didn't matter. It's a horrible smell. But if somebody hit that with a little tunnel, that would have been a big problem for the thing. But I'd say Appendix J, and it always, moderate my language, disappoints me how little people know about that. I gave a presentation a couple of years back, one of the consultants about tunneling machines. I threw that one in, and I asked about it, and their director said, "Oh, I've got a copy." And he turned to the rest of the people. I said, "Well, why the hell haven't you passed it around?" Oh, bingo. And sorry if I stop you from being in the bar. Apologies.
And just to advertise myself as well, if you have any boreholes on your alignment, contact me. I have a good experience now decommissioning them. All right.
Thank you.
Thank you, everyone. Can we move to the announcement slides? Yep, 50 years of service. We have completed 50 years back in 21. Get the book if you haven't already. Foods and drinks, and sponsored by Balfour, Beatty, and VINCI, working in partnership with HS2. So,
just drinks.
Oh, just drinks. All right. Change the slides, Devik, already.
Cost cuts.
Sorry, we are cheap.
Carry from last week.
Yeah. All right. Tuesday, 10th of March. So, ITA and ITYM online event celebrating International Women's Day. The topic will be Leading from the Front, Women Who Contribute to the Tunneling World. There will be a panel discussions with the BTS representatives from the UK. Next one. March 16th. This is an event that the YM have organized with UCA-YM from the US. We're calling it People, Plant, and Pixels. So essentially, we'll be talking on sustainability, innovation, and inclusivity from across the pond. So it's a joint event that BTSYM and UCA-YM is doing. It's one of the two tunneling associations in the US. Next one. This is a 19th of March BTSYM workshop. So if you ever heard of timber headings, then you might be interested. And if you haven't, then definitely go and attend. It's a totally different side of tunneling, which you haven't seen if you're a young member.
A lot more done than you think.
Lot to learn. Next one. 19th of March, we'll be having the Harding Prize presentation. This year, it has been very, very competitive, and we have received a lot of good entries for this. There are some presentations which could have won Harding Prize in the previous year, so it's been very, very close this time. You will definitely don't want to miss this one. Next one. 16th of April, we have the Hinkley Point C Marine Works and Shaft Connection. This is the main BTS lecture. The speaker will be Barry Gilsonen from the Senior Tunnel Manager at Balfour and Design Representative from the Jacobs. Next one. So again, a YM site visit. Very own Alison Rake has taken the initiative to organize one for us. Thank you. She's in the crowd. Cheers to her. So this will take place on the 6th of March. Soon we will be sending the link to join the site visit for the young members who are interested. It's always good to have a mix of people to attend this one. It's open to young members. Next one. Yep. So the next bursary for to attend the World Tunneling Congress is not quite far. So this one is next year, not this one in Montreal. So this one is in Antwerp. So for those of you who want to visit Antwerp for the World Tunneling Congress, the young members, please take note. Next one. The BTS Annual Dinner 2026. It will take place on 8th May 2025 at the brewery, and yeah, don't have to, it's quite self-explanatory. Next one.
Well, there is a young members ticket there, so it's half price for young members and retired members. The individual tickets.
The BTS Design and Construction course will be held from the 6th to the 10th of July at the University of Warwick. It's definitely an attend. It's quite rigorous, so be ready for a week of tunneling trivia, and hope you can keep up. Next one. Registration is open now for the BTS Conference and Exhibition 2026. Early bird rates are right now there, so be the early bird and register. It will be a 2-day conference, great price, just close by as well. So Queen Elizabeth Center just across the road. Yeah, next one.
And if you're a fully paid BTSYM member, you're eligible for 20% discount at the YM rate. So yeah, so 20% discount. And if you're a student or an apprentice, then you can write to Gary from Tunneling Journal, and there are a few free places for students and apprentices for grabs.
A detailed communication will be sent to you by CAT, so whatever the Vic is saying. Yep. Thank you. Track the above dates using the BTS events calendar on the website. So now we have updated the website. Go there, log in. It's a bit of a maze to find out based on personal experience, but we are just simplifying it as much as we can this year. So try to use it more interactively. We'll send the links across in our communication as well. Next one. Take your phones and scan the QR code. This is for the sprayed concrete linings in soft ground. It's been published recently. It's free for those who are interested. And yeah. Next one. Yeah. The BTS nominations in elections 2026. Again, if you're considering joining BTS as an individual or corporate member, please scan the QR code. You can see the dates for the nominations for elections. If you're interested in joining the committee, please take note of the dates.